Chapter Light is made of material particles and is the basis of all matter. It seems very likely that light is made of material particles and is not a transverse electromagnetic wave as is currently claimed. All galaxies, stars, and planets are corpuscular, so it seems logical that light is made of corpuscular bodies too. In fact, all matter is probably made of light particles, and the explanation is simple. When we light a candle, light particles from the candle and oxygen in the air are emitted into our eyes from the flame, and as time continues, the candle is made smaller in size. The only logical conclusion is that the light particles were in the candle and oxygen the entire time, and that the candle and all atoms are simply made of light particles, that the light particle, the photon, is the basic atom of all matter. This is true even for the so-called antimatter, because when a proton and antiproton collide, the result is not empty space, but instead, of course, all matter is conserved and emitted as light particles and other larger fragmentary particles also made of light particles. Even antiparticles are made of photons. All other particles besides photons, including atoms and molecules, are composite particles. This includes all the subatomic particles, mesons, etc., too, all made of light particles. The claim of relativity that light is massless is absurd, in particular when we realize that light is the basis of all matter, the most fundamental atom that all matter is made of. Perhaps even light particles are made of smaller particles. It's useful to just quickly summarize a little history about the various explanations of light given to the public over the last few centuries. Long ago, around 56 BC, the Roman writer Lucretius described light as being made of atoms that move very fast. The collapse of science and the rise of the Dark Ages delayed progress until around 1228 AD, when the first president of the newly established Oxford University published a book theorizing that all matter is made of light. So this idea of light being made of material particles and being the basis of all matter is not only not new, but is really pretty ancient. A more precise explanation of light did not reach the public until 1664, when René Descartes' book Le Monde was published, 18 years after his death. In Le Monde, Descartes revives the theory that light is made of particles, comparing light to a ball, and is the first to describe the two major theories of light, the wave and corpuscular theory. So Descartes is really a hero for comparing light to a ball. It's interesting to note that the earliest wave theories are corpuscular wave theories. The wave is made of a material particle medium. The wave theory is probably more accurately called the constant collision theory, because in this theory, light is transmitted by the constant collision of material particles that fill space, while the corpuscular theory is probably more accurately called the rare collision theory, because in this theory, light is transmitted by particles that move through mostly empty space. It may be that inside dense objects like planets and stars, light particles constantly collide, and without moving much, like the wave theory describes. But when light particles reach the surface and empty space, they rarely collide, like the corpuscular theory describes. In any case, a year later in 1665, Robert Hooke and Francesco Grimaldi firmly established the so-called wave theory for light, in which light is a motion through a medium of constantly colliding particles. And in 1672, Isaac Newton more clearly and firmly established the so-called corpuscular theory for light, in which light is made of material particles, corpuscles, that move through any medium. Newton compares the motion of light to a tennis ball, just as Descartes did. Many people recognize Isaac Newton as being the founder of the theory of gravitation, but few people know that Newton heroically established the corpuscular theory of light, which is perhaps of equal importance to the theory of gravitation, especially when we realize that material particles of light are probably the basis of all matter. So initially everybody agreed that light was made of material particles. The disagreement was only how light is transmitted, by many collisions of particles as a wave like sound in air, or by particles moving mostly through empty space like a ball. The corpuscular, or mostly empty space, rare collision theory of light, in my view the more logical and accurate theory, held popularity for about 100 years. This period was, in my opinion, a bright and progressive period for science. But all that changed, at least in terms of physics. The rebirth of logical and intuitive science of the 1700s collapsed in the early 1800s, and we still live in the dim era that resulted. In 1801, Thomas Young was the first person to publish the frequencies and wavelengths, or particle intervals, of various colors of light, which is a great achievement. But Young supported a wave theory for light in the same paper. Young advanced the idea that rays of light interfere with each other, an effect for light similar to that for sound, where two sounds will cancel to produce places of silence. The analogy being that two waves of light may cancel to produce places of darkness, which I examine in more detail later. Young, in 1817, changed the traditional wave theory to claim that light is not a forward and backward, longitudinal or point wave, as Descartes and then Hooke had described, but instead is a transverse wave, a wave with an amplitude. Young felt that a transverse wave could better explain the phenomenon of light interference. Augustin Fresnel, in 1821, also sided with this transverse wave theory. Sadly, this, in my opinion, unlikely wave or undulatory theory replaced the more logical corpuscular theory in popularity. As an aside, many people probably don't know that Young is credited with being the first, in 1807, to formally apply the word energy, the currency of scientific theories from the 1800s on, to Leibniz's vis viva, living force, quantity, mv squared, of 1695. Moving on with the story, James Clerk Maxwell in 1864 and 1873 accepted and adjusted Young's transverse wave theory by supposing that light is made of not one transverse sine wave in an ether, but instead is made of two waves, one an electric wave and the other a magnetic wave, both positioned at 90 degrees to each other. And this, in my humble view, very unlikely electromagnetic interpretation has shockingly held to this sad day. For example, the spectrum of light is still called the electromagnetic spectrum. But the corpuscular side fought back, and in 1881 Albert Michelson, a master in the U.S. Navy, reported an experiment that showed that the speed of light is unchanged relative to the motion of the Earth around the Sun through the supposed ether medium. If there is a medium for light, and it is stationary relative to the motion of the rest of all the matter in the universe, then this motion should make the light waves take less time in the direction of the Earth's motion around the Sun, but this wasn't found. Michelson was even so bold as to write that the result of the hypothesis of a stationary ether is thus shown to be incorrect, and the necessary conclusion follows that the hypothesis is erroneous. And then giving a final stamp of approval from none other than the DWW specialist himself, Alexander Graham Bell, writing, "In conclusion, I take this opportunity to thank Mr. A. Graham Bell, who has provided the means for carrying out this work. Without any ether medium, it is hard to imagine light as a wave." This made the corpuscular theory for light appear to be the more accurate interpretation. But like the Empire, the wave camp struck back. To explain this experiment of 1881 and the mysteriously more popularized experiment of 1887, and to try to save the theory of light as a wave that moves through an ether medium that fills the universe, George Fitzgerald in 1889 developed a theory that matter contracts just enough to account for the absence of any apparent difference in the speed of light that would be due to the movement of the Earth through a stationary ether. In 1892 and 1899, Hendrik Lorentz threw his support behind this theory and expanded it by saying that not only does matter contract in the direction of motion just enough to offset its motion through a stationary ether, but that even time itself can be contracted or dilated depending on the motion of matter. Lorentz theorized that instead of there being one time for all of the universe, each piece of matter has its own time. Most of us can probably recognize these theories as being doubtful. Michelson rejected these unlikely explanations even as late as 1927, writing, "Lorentz and Fitzgerald have proposed a possible solution of the null effect of the Michelson-Morley experiment by assuming a contraction in the material of the support for the interferometer just sufficient to compensate for the theoretical difference in path." Such a hypothesis seems rather artificial, and it of course implies that such contractions are independent of the elastic properties of the material. The next big development happened in 1900 when Max Planck partially revived the particle theory for light by theorizing that objects emit light in individual units he called energy elements, but which were later called quanta. Planck created a simple equation, E equals hv, where E is an energy element, h is a constant, and v is the frequency of emitted light. In my view, Planck's quantum theory will be remembered mostly for partially reviving a particle theory for light, because most of the energy work of the 19th and 20th century, like the theories of relativity, are abstract and overvalued, especially when looking at the secret and more practical development of robots, rockets, transmutation, RNRAW, and nanoscale particle devices. Albert Einstein was an early supporter of Planck's quantum theory and applied it to describe the photoelectric effect, famously in March of 1905. So Einstein initially appeared to be a supporter of a corpuscular theory for light. I had said that it is hard to imagine light being a wave without an ether medium, but Albert Einstein could, and did. In June of that same year, Einstein published his famous special theory of relativity, which adopted the far-fetched ether-saving theories of Fitzgerald and Lorentz that matter and time contract depending on the speed of a material object relative to a stationary ether, but in an ironic twist, and perhaps as a compromise with the, by that time, nearly extinct corpuscular school, Einstein rejected an ether medium for light as being superfluous, choosing instead to base motion relative to an observer. In this view, the mass of an object increases the faster it moves, gaining mass from some unknown source, and time, as experienced by the object, slows down the faster it moves relative to, presumably, the rest of the matter in the universe. In September of 1905, Einstein publishes his famous E equals mc squared equation, originally m equals L divided by c squared, which, to Einstein's credit, at least suggests the theory that all matter might be made of light, but to me at least implies that matter and motion can be converted into each other, and that mass has some inherent motion, both of which I doubt. Then 10 years later, in 1913, as if matter and time contraction and dilation depending on motion is not unlikely enough, Einstein, with help from Marcel Grossmann, expanded this theory and adopted the radical and unlikely surface topology, so-called non-Euclidean geometry, which I describe below, to try to explain the movement of matter in the universe in his famous general theory of relativity. It is, in my humble opinion, and with all due respect, very unlikely that a restricted surface geometry applies to the movements of matter through time in the universe. But as radical, extreme, and unlikely as applying a surface geometry to the universe may seem to me, this explanation is currently the most popular. In 1922, Louis de Broglie joined Planck's E equals hv with Einstein's E equals mc squared to solve for the mass of what he called atoms de lumière, atoms of light. The mass of the light quantum is now described as its rest mass, because of the doubtful, and no doubt deliberately dishonest, claim that motion changes a body's mass. De Broglie didn't give an exact number, but simply supposed that light atoms have a masse très faible, very low mass. This raises the startling truth, although I haven't scoured the archives, that no actual mass of a light particle in terms of grams has ever been made public. In 1909, Jean Perrin described the mass of an electron taken to be 1,000 times less than Avogadro's number as 0.805 times 10 to the minus 27 grams. So perhaps the actual mass of light particles in terms of grams is 1,000 times smaller, around 1 times 10 to the minus 30 grams. It also raises the point that, really, the light particle is perhaps a better base unit of mass than an atom is. Perhaps we should describe small masses in terms of number of light particles. Finally, around 1927, Arthur Compton coined the phrase photon for the quantum of light. Note that the term photon is currently not defined as a material particle, as I am saying it should be, so perhaps it should be officially redefined, or a new word should be created like luxon or lighton for the ancient interpretation of light as made of material particles. So that brings us to the present time, where chaos still reigns and truth is still viewed as disease.